Well, we've been talking about flying a lot this week, haven't we, with various things, be it Ryanair, be it Monarch. But flights in general around the world could get more bumpy, according to the first ever global projections of in-flight turbulence. The study, led by the University of Reading, calculated that climate change will significantly increase the amount of severe turbulence by 2050 to 2080. Professor of Atmospheric Science at the university is Dr. Paul Williams, and he led the research. Paul, hello to you.
Hi, Phil.
I can imagine if there are going to be more extreme weather patterns suggested by climate change, yes, I can see why turbulence could be, affecting us a bit more.
Well, it's interesting, isn't it? Because we tend to think of the climate changing at ground level. Of course, that's where we spend most of our time. But many people spend a good number of hours up at 35,000 feet. And the climate is changing there as well. The jet stream at those flight cruising levels is speeding up over the North Atlantic. We think it's sped up by a few miles an hour compared to a few decades ago. And basically, a stronger jet stream means more turbulence.
Right. Perhaps quicker flights if you're going from the US to the UK. I imagine if you've got a jet stream behind you.
But the other side of that coin is longer flights if you're going westbound because of the stronger headwinds. So there's pros and cons to everything.
Exactly. Are there going to be parts of the world that will be affected more than others?
Well, it does seem like Europe in particular, according to our calculations, will have 160% more severe turbulence. And this is the turbulence that's strong enough to catapult people around inside the cabin because it's stronger than gravity. So places like Europe, the North Atlantic with 180% more turbulence, North America with 110% more turbulence. So it's slightly ironic that it's those really busy flight routes, which are precisely where the jet stream is and precisely where the increased turbulence is happening as well.
Wow. Is it going to be safe to fly with that sort of increase in turbulence?
It is going to be safe to fly, and I always emphasise this. No one should stop flying because of a fear of increased turbulence. Severe turbulence is very rare, and even if we see twice as much of it in future, or even 3 times as much of it, it will still be rare. So the chance of your particular plane on a given day encountering that very small atmospheric volume containing severe turbulence is small. However, you multiply that by the number of planes in the sky at any time, and you won't have to wait very long before one of those planes randomly encounters that severe turbulence. So no one should stop flying because of this, but I think passengers can expect to be seatbelted for a lot longer with the seatbelt sign on, and that's obviously frustrating for everyone.
Yeah, so you can't imagine it will deter people from flying?
Well, that's a very interesting point because we see all of these impacts of climate change, and that's all about often heat waves and flooding events and extreme weather that really affects people at ground level. I do wonder whether there are people out there who fly a lot for whom 3 times more severe turbulence might be the first thing that makes them think about their carbon footprint and about reducing it. So very interesting question, yeah.
Yes. Whatever happens, when it comes to the turbulence, especially you were talking about the jet stream finally, can you see it getting worse after 2080 as well? Because surely you're going to have even more concerns about climate change then. Or do you think we may have sorted some of those problems by then?
Well, that's the million-dollar question, Phil. And as you say, our study goes up to the 2080. Quite what happens beyond then depends on our future carbon dioxide emissions and whether we manage to cut them by that stage. That's obviously a question for policymakers. So I have no expertise in that, but I would say that the more CO2 we keep putting into the atmosphere, the stronger that turbulence will get and the more frequent it will get.
Paul, good to speak to you. Thank you very much indeed. That's Dr. Paul Williams, who led the new research at the University of Reading. He's a professor of atmospheric science. Apparently, more turbulence. I think Theresa May knows about that.
BBC Radio Berkshire.
A lot of turbulence today.
As it happens.
A lot of incoming.